Hey Titans, it's Mr. Spilker here, and we are going to cover Chapter 13, Section 5, which is all about simulations. Let's dive right into what a simulation is. A simulation imitates a real-life situation. A simulation is supposed to give similar results. It acts as a predictor of what should actually happen in the real world. It is a model in which repeated experiments are carried out for the purpose of estimating what would really happen in real life. When designing a simulation of an actual event to approximate an experimental probability, you must do the following. Number 1, choose a random number generator such as a coin toss, number cube roll, calculator, computer, or other method that can be used to simulate the situation. Decide how to perform the experiment so that it simulates one trial. Perform a large number of trials and record the results. Then use the number of favorable outcomes and the number of trials to compute the experimental probability. Alright, let's jump right into an example here. A medication is predicted to work 2 out of every 3 times. So the question here is, what could be used to simulate the medication working? Obviously, we wouldn't want to just start handing this medication to people and see, okay, is it going to work or not? We want to be able to simulate the medication working and find the experimental probability. So what could we use to simulate the medication working? Think about that. One idea that I have off the top of my head would be to use a number cube. We could roll the number cube, and we could have 1, 2, 3, and 4 mean that the medication is working. And we could have 5 and 6 mean that the medication is not working. So therefore there would be a 2/3 chance. Question B says, describe a way to simulate the effectiveness of the medication on 10 people. What we could do is we could take the number cube and roll it 10 times. If it came up a 1, 2, 3, or 4, then yes, it works. If it came up a 5 or 6, then no, it does not. So a number cube could be used to simulate this situation without having to actually give people medication. Here's a second example. Suppose that 90% of the flights for an airline are on time. Explain how to design a simulation to find the experimental probability that 3 consecutive flights are on time. So how could we simulate this? Think about that. One idea I have would be to put 10 pieces of paper in a hat. Mark 9 of them as yes, the flight being on time, and mark 1 of them as being no. Then go ahead and draw from the hat. Draw 3 consecutive times, and each time make sure you put the piece of paper back so that each event is independent. Then record your data, and you could find the experimental probability that 3 consecutive flights would be on time. The last example I have says, suppose there is a 50% chance of rain on Saturday and Sunday. Explain how to design a simulation to find the experimental probability that it rains both days. The simulation I would design here would be to use a coin. I would flip the coin and I would say, heads is rain, tails is no rain. I would flip it once for Saturday, once for Sunday, record my data. I would then do several trials of this so that I could have a large portion of data so that I could find the experimental probability that it would rain both days. So I would use heads as yes it rains and tails as no it doesn't. So as you can see, we can go ahead and model many real-life situations by using a simulation with a simple tool such as a coin, a number cube, or putting pieces of paper in a hat. And once again, guys, it's going to be up to you to be clever here to come up with ways in which you could simulate these real-life events to find the experimental probability. Thanks for listening. That's Chapter 13, Section 5, Simulations.
Made with Doodlecast Pro.